Hello everyone and welcome to lesson 24 of the Save My STEM Physics channel. This is going to be the second lesson of mechanics, and we are going to be covering the equations of constant acceleration, otherwise known as SUVAT. So first, what is SUVAT? I'm going to write it out like this. SUVAT. S is the letter for displacement. U is initial velocity. Some of you, if you go onto physics further, or if you look at previous physics books, or maybe the Feynman lectures, may see this referred to as V naught, V subscript 0. That subscript 0 is used in many areas of physics to represent the initial or the natural version of something. So another example may be in a spring, its natural length could be denoted as L naught. We have V, which is its final velocity. That is typically just referred to as V. There's no subscript there. A is the acceleration. Notably, for SUVAT, the acceleration has to be constant. And T is the time. So, now that we have all these values known, what can we do with them? And this is where our equations come in. So there are five unknowns. There are five unknowns, and each equation has four unknowns, which means that with knowing any of these three letters, we can figure out both the other two letters. And I will write down all the equations and show that to you in a second. So, I have my formula book here, and the equations here are as follows. V equals U plus AT. So, I'm just going to get this written down. V equals U plus AT. S equals U plus V over 2 multiplied by T. V squared equals U squared plus 2AS, and S equals UT plus a half AT squared. Now, these are the four that are listed in the formula booklet. Sorry, that T is really far away. I'm going to rewrite that. You're just going to have to believe me and say that says AT squared. It was just written really weirdly. But there's one formula that isn't in the book, which is very similar to this one here, which is S equals VT minus a half AT squared. It is effectively the same formula, just the other way around, to describe it in terms of its final velocity and not its initial velocity. And from these equations here, we can see how we can find any possible value. So, take for example that we know what S is, and we know what U is, and we know what V is. We can calculate A using, let's check. So this equation doesn't have S. So we're not going to be able to use our value for S, so we're going to ignore this equation. This equation does have S. Boom. Now let's go and check. Does this one have U? Yes, but it doesn't have S, so we're going to ignore it. Does this one have U? Yes. Boom. Does this one have V? Yes. Boom. So using this one, we can find our time. So we can use this equation, knowing S, U, and V, to find the time. And now let's check for the others. Does this equation have S? Yes. Does this equation have U? Yes. Does this equation have V? Yes. So using this equation, we can find the acceleration. And that is basically how it works. You can take any three unknowns, check which equations have all three of those in, and use that to find the fourth unknown in that equation. And yeah, that is the equation. Those are the equations of constant acceleration, or SUVAT, and those are how they work. And we use these to describe the motion of an object. All of these formulae are derived from graphs. So basically from the graphs that I discussed in the last lesson, um, where this equation is the area underneath the graph, uh, which which you might have been able to see in the last video, um, because this is basically the area of the triangle, assuming that it's a constant acceleration. So that's the area underneath the velocity time graph giving us displacement. That equation works. This equation is effectively just the equation for a velocity time graph, where u is our y-intercept, our initial, a is our gradient, and t is our x-axis function. The others are a little bit more complicated to derive, but they are still derived from the graphs and they are derived through these. And yeah, so I'm not going to go through those proofs right now because frankly, I don't know them, but feel free to search them up for yourself to get some more enlightenment on that. And I hope that this video has helped a lot with understanding what SUVAT is and how they work. Thank you very much for watching, and I will see you all in the next one.